right here. Formula 1, area in general is going to be 1/2 base times height of a triangle. This is our first triangle area formula, and sometimes we'll use this one, sometimes we'll use one of our other variations. We're going to use this when we know the base and height. Now, height is not just a relative term here. Height means perpendicular height. Height would be the distance from one vertex to an opposite side, and it's got to be a perpendicular distance, which implies the shortest distance. So here's an example of when we would use that. We're given the NS is perpendicular RP. There we have the right angle in there. NS is equal to 12. RP is equal to 4. And since we have a base, we have the height going from one vertex to this side, we're going to use this formula that we just went through. 1/2 times our base times our height. Multiply all that together. We get an answer of 24 units squared. For all these labels, it'll either be units squared, centimeters squared, inches squared, always some type of units that will be squared. So there's our Formula 1. When we know the base and height, we'll use 1/2 BH. Formula 2. Area equals. Now this one's a little bit more complicated, but there's a reason why we're going to use it. Big square root of S times S minus A times S minus B times S minus C, where S is equal to A plus B plus C divided by 2. Prior to this class, you probably haven't looked at any other formulas to find the area of a triangle. We're going to look at 3 different ways we can find the area, and it's depending on what we know about the triangle. We've solved triangles recently. If it's a side-side-side case, we can use the law of cosines to start solving it. If it's a side-angle side, we can also use the law of cosines. In this one, this formula will give us the area of a triangle, and we're going to use this when we have all 3 sides of the triangle, or when we have SSS. This is another tool for us to use, another way that we can find the area when we don't know the base and we don't know the perpendicular height. So let's go into an example of this. It says NU is equal to 8, US equals 11, and NS is equal to 13. So we know all 3 sides of the triangle. That's when we would be using this type of a problem or this type of an equation. And the green formula that I have highlighted is actually what finds the area, but we have to find this little s value. Little s stands for the semi-perimeter. Perimeter is the distance to go all the way around the object. Semi means we're splitting it into 2. In other words, what is half of the perimeter? So we're going to add up all these sides together, 8 plus 11 plus 13. And then we're going to divide that by 2. And that comes out to 16. Again, S. Find that S value. Find that semi-perimeter. Because once we know that, now we can go after actually finding or calculating that area. Area equals big square root of 16. Then in the formula it says 16 minus A. Well, little a is one of the sides, little b is another side, little c is the third side. So we'll just go in order. 16 minus 8, 16 minus 11, and 16 minus 13. Before I go to my calculator to actually get a decimal approximation for this one, I'm going to simplify the inside a little bit. 16, then 16 minus 8 is 8, 16 minus 11 is 5, 16 minus 13 is 3. So those numbers are going to be easier to multiply. If you want to go to your calculator for that, you can. We get the square root of 1,920. And we're just looking for a decimal approximation here, so go ahead and take the square root of that number. And it comes out to about 43.82 units squared. So if you know all 3 sides of the triangle, we can use this formula. It's called Hero's formula. Sometimes called Heron's formula. Since Alex Wriggling is all about the superheroes, we'll call it Hero's formula rather than Heron's. 1/2 base times height. Hero's formula when we know all three sides of the triangle. And now we've got one more. This is 1/2 times little a times little b times the sine of big angle C. Yet another tool for us to have. We're going to use this when we have side angle side. So last time we had a side, side, side. We didn't have to solve the triangle. We wanted to find the area, so we could use that Heron's formula, the Hero's formula. Now we have side angle side. We're not trying to solve the triangle. We're just trying to find the area. We're going to use this one. Now it's actually applied to a problem. HN is equal to 8. NW is equal to 9. And angle N is equal to 92 degrees. So there is our side angle side. If you look at it in order, we have a side, then the next angle, then the next side. So to calculate this area then, we would take 1/2 times 8 times 9 times the sine of 92 degrees. Just plugging everything in right now. I'm going to simplify it a little bit before I go to my calculator. 1/2 times 8 is 4. 4 times 9 is 36. So a simplified way to put it into the calculator is just 36 times the sine of 92. And that comes out to about 35.98 units squared. The next formula we're going to look at is the formula for the area of a rectangle. The area of a rectangle is base times height. And we're not going to write down use this when. That's just always the way we're going to find the area of a rectangle. Multiply the base times the height. That's the area. So in this example, ABCD is a rectangle. AB is equal to 8. AD is equal to 12. So 12 is the base, 8 is the height. We're going to multiply them together, and we get exact 96 units squared. Base times height for the area of a rectangle. Next up is square. Area equals S squared. We have two formulas for the area of a square. Here's the first one. Area equals S squared. Use this when we know the length of the sides. All four sides in a square are congruent. If we know one of the lengths, then we know all of them. Instead of doing it as base times height like we had before, this is just really a variation of that. Since the base and the height would be the same length, we just multiply the length by itself. So in this one we have a square, AB equals 6. That means all of the sides are equal to 6. If we treated it like a rectangle, which it is, we do 6 times 6. We're using this formula, we just take 6 and square it. They're essentially the same thing. So area equals 6 squared. So the area of this square is 36 units squared. Here is our other formula for the area of a square. Area equals D squared over 2. Now S stands for the length of each side of the square. D stands for the diagonal. So if you go from one vertex to a vertex on the opposite side, or you go diagonally through the square, that's called the diagonal. Use this when we know the length of a diagonal. Both diagonals are going to have the same length, so if we know one, we know the other one. So in this one, the length of BD is equal to 8. So what we're going to do with that is square it and divide it by 2. 8 squared is 64. 64 divided by 2, 32 units squared. All the triangle examples, one rectangle, two square formulas. Now we have a trapezoid. Formula, area equals B1 plus B2 divided by 2 times the perpendicular height. We have 3 different variables in this one. We haven't had that many variables yet, so we have to make sure we understand what they're talking about. B1 is one of the bases. B2 is the other base. Those are the two sides that are parallel to each other, and they're never the same length. So we're going to add the length of those two bases together and divide by 2. In essence, we're finding the average length of the bases. Whenever you add two numbers together and divide by 2, that is finding the mean or the average. So we're finding the average length of the bases, then we're multiplying it by the perpendicular height, the distance between those two bases. Let's go ahead and go into this example then. We're told that this is a trapezoid. AB is equal to 8, DC is equal to 14, BE equals 7, and we're told that it is perpendicular. So then the way we would find the area of this one is to add together the two bases, divide by 2, multiply by the height. And I want you to remember that this part of the formula on the inside, the B1 plus B2 divided by 2, is just the average of the bases. Sometimes the problem might tell you, here is the average of the bases. In that case, that's giving you everything that I have highlighted in green. Because we're given the bases individually this time, add them together, divide by 2, that's 11. 11 times 7 gives us an area of 77 units squared.